Well, hello and welcome back to math class. You will notice that we are going to go ahead and move on to lesson 9. We are still working with equivalent ratios, but we're going to actually turn them into tables. This is a table right here. Remember, we're in lesson 9, mod 6-1. So if you could open up your books to this page, S31, we will get started. All right, example 1 says, to make paper mache, the art teacher mixes water and flour. For every 2 cups of water, she needs to mix in 3 cups of flour to make the paste. All right, so we already know we can find our ratio. 2 cups of water, 3 cups of flour. It says we're going to find equivalent ratios for the ratio relationship 2 cups of water to 3 cups of flour. Represent the equivalent ratio in the table. So for example, if I put this piece of paper here, and I'm going to put a 2 here for 2 cups of water and 3 cups of flour. Now, if I want to make a bigger batch, I'm going to make it another 2 cups and another 3 cups of flour. If I want to make even more paper mache, I'm going to keep adding 2 cups for my water, 3 cups for my flour. But if you noticed, making a table like this is not giving me any information. I would have to count 2, 4, 6, 8, 10 cups of water, 3, 6, 9, 12, 15 cups of flour. This doesn't help. So what we want to do when we make our table is we want to do this. I know that I'm going to have 2 cups of water. That's what the ratio says. And 3 cups of flour. If I want to make another batch of an equivalent ratio, I would not add another 2. I would know that I would have a total of 4 cups of water and a total of 6 cups of flour. Okay, another equivalent ratio, I'd add another 2, which means I would have now 6, add another 3, 9. Let's keep going. Add another 2 on, and add another 3 here. And our last one, some of you are noticing a pattern. 2, 4, 6, 8, 10, 3, 6, 9, 12, and our last number is 15. Well, when we were doing equivalent ratios last week, we did something like this. We multiplied it times 2. Whatever we did across the top, we had to do along the bottom. And that gave us 4/6. I could have taken this number here and I could have multiplied it times a 3, which would have given me 6. And I could have taken this and I could have multiplied it times a 3, which would have given me 9, 6 9ths. Okay, so we're doing the same kind of concept, but we're putting it in a table form. So if you will notice from here, what did we do? From here to here, we added 2. We would continue to add 2 all the way down. On this side, what do? We added 3. And from 6 to 9, we added 3. 9 to 12, we added 3. And 12 to 15, we added 3. So a little pattern here that you might have noticed. Now, what I want you to do is I want you to go ahead and write the word value over here to the side. Okay, do you remember what value is? The value of a ratio is when we make it and put it into lowest terms. Okay, we simplify it or we reduce it. So the first value we have here is 2/3. I like to do my values like this. Now, if I would look at my factor sheet, 2 and 3, the only thing that they have in common is a 1. So this is as low as this gets. If I look at 4/6, and I look at my factor sheet, I will know that 4 and 6 both can be divided by 2. And if I divide them both by 2, I get the answer 2/3, which is the same as the first one. Let's try 6 9ths. What can I divide this by? They both have Ooh, they both can be divided by a 3. 6 divided by 3 is 2. 9 divided by 3 is 3. Let's try 8/12. If I look at my factor sheet, the largest factor that goes into 8 and 12 would be 4. 8 cut in 4 would be 2. And 12 divided by 4 would be 3. Let's look at the last one. 10 over 15. My ratio 10 to 15. How could I find the value? Oh, they both could be divided by 5. 10 divided by 5 would be 2, and 15 divided by 5 would be 3. Look very carefully and tell me what you see. The ratios do not look the same, but they are equivalent to each other because you will notice that all of their values are the same. So either highlight their values over here, circle it, somehow mark it so that you can see their values. The values are all 2 to 3. When you're finished, go ahead and turn to the next page. Okay, what do you notice about this table? You will notice this table does not go up and down. This table runs from left to right. Okay? Tables can go either direction. They can go either up and down or left and right. You will remember on the table on the first page, we had labels of water and flour. Here we have labels of total pages built and total money earned. Let's read our situation and see if we can find the ratio. Javier has a new job designing websites. He is paid at a rate of $700 for every 3 pages of web content that he builds. Create a ratio table to show the total amount of money Javier has earned in ratio to the number of pages he has built. Okay, I see the ratio right here. He's raised $700 for every 3 pages. So if I look at my table and put the numbers in the correct location, total pages built, that would be the 3. And the money earned is $700. So I'll put a dollar sign here to know we're talking about money. Okay, we're going to do the same thing that we did on the front page. We're not going to keep saying 3, 700, 3, 700, 3, 700 because that's not going to give us enough information. So obviously for every 3 pages, we get $700. Well, let's do another 3 pages. That would mean I have a total of 6. And then if I make $700 for every 3 pages and I have 6 pages, which means I did 3 for $700 and I did another 3 for $700, what would 700 and 700 be? That would give me a total of $1,400. Okay, so you notice right here on the top we're counting by 3s. So I have 3 pages for $700. I did another 3 pages for 6. I'm going to do another 3. So if I had 6 pages and that was $1,400, and I added 3 more to get 9, that means I need to add 700 to this. That means I'm making $2,100. All right, I'm going to ask you to pause your video and see if you can go ahead and fill in the rest of this ratio table. All right, well, let's see how you did. So we stopped here with the 9 pages built. Our next number should have been 12 pages for $2,800. The next would be 15 pages for $3,500. 18 pages for $4,200. And 21 pages for $4,900. And I think there we go. That's our last one. Is 24 pages. We will make $5,600. Question down here says, Javier is saving up to purchase a used car that costs $4,200. How many web pages will Javier need to build before he can pay for the car? He needs to make this much money, which looks right here, which to me says he needs to do 18 total pages. So I went ahead and wrote it out as a sentence. It says Javier will need to build 18 web pages in order to pay for the car. So the answer to my question, how many pages? 18 web pages. Now, if I wanted you to find the value for each one of these ratios, which I'm not going to have you do them all, but if I would put that, we would remember that value means reducing this ratio. Well, 3 to 700 is actually as low as it will go. This will not simplify. But if I looked at the next one, if I did 6 and 1,400, both of these could be divided by 2. 6 divided by 2 is 3. 1,400 divided by 2 or cut in half would be 700. So I would continue, because all of these are equivalent ratios to each other, their values should all equal this. Okay, go ahead and flip over to the next page. Okay, spraying plants with cornmeal juice is a natural way to prevent fungal growth on the plants. It is made by soaking cornmeal in water, using 2 cups of cornmeal for every 9 gallons of water. Complete the ratio table to answer the questions that follow. Once again, here's our ratio. 2 cups of cornmeal, 9 gallons of water. So we would write the correct number with the correct title. Cups of cornmeal, this would be 2. Gallons of water, 9. Pause your video and go ahead and see if you can fill in the rest of this table for me. All right, well, let's see how I did. I did 2 and 9 together. Your next equivalent ratio should be 4 to 18. After 4 to 18, we have 6 to 27, 8 to 36, and 10 to 45. Remember, these are all equivalent ratios. Let's look at what A asks. A says, how many cups of cornmeal should be added to 45 gallons of water? All right, so here's the water, 45 gallons, so we need 10 cups of cornmeal. Okay, making a ratio table sure makes it easy for us to answer these questions. Let's look at the next one. Paul has only 8 cups of cornmeal. How many gallons of water should he add if he wants to make as much cornmeal juice as he can? So 8 cups of cornmeal, so we need to go to the cornmeal side, find the 8. How many gallons of water? The answer is 36 gallons of water. Okay, let's move down to C. What can you say about the values of the ratios in the table? Well, we don't have the values listed up here. We could list them to make sure we can see 2 to 9. Okay, 2 to 9. You cannot reduce 2 to 9. There's not a factor that they both have besides 1. 4 to 18. These are both even numbers, so we could cut them both in half and get 2 to 9. 6 over 27. Well, we all know we want it to equal 2 9s, right? What are we going to divide them by? Oh, looks like we're going to divide them by 3. 8 over 36. We want it to equal 2 9s. Does it work? We could divide them both by 4. 10 over 45. How can I have it equal 2 9s? Divide them both by 5. Once again, what did we say about the values? Well, they're all 2 9s. Okay, so it says the values of the ratios are equivalent. They were all equal. All right, when you're ready, go ahead and flip over to the next page. Okay, so this is the last problem we're going to look at. It says, James is setting up a fish tank. He is buying a breed of goldfish that typically grows to be 12 inches long. It is recommended that there be 1 gallon of water for every inch of fish length in the tank. What is the recommended ratio of gallons of water per fully grown goldfish in the tank? Well, I saw the number 12 here. I see number 1 gallon here and another 1. So I'm not quite ready to fill in my ratio yet. So let me think about this. So according to my story, a fish can grow to be 12 inches long. And that fish, so I have 1 gallon for every inch. So for example, don't laugh at my drawings. We have here our 1-inch fish. He gets a 1 gallon tank. Well, if the fish grows, guess what happens? The tank has to get bigger. And as the fish grows even more, the tank has to get bigger. And if the fish grows even more, the tank has to get bigger. Well, this would be a lot of waste in buying all of these tanks, correct? We're going to expect that this fish is eventually going to become 12 inches long. Even though he started off this tiny, he's going to eventually grow. I don't want to buy all of these aquariums. I'm going to go ahead and buy an aquarium that's very large for my fish, but is one that I know he has plenty of room to grow in. So if he's going to grow to be 12 inches like this, so the fish is 12 inches long. How many gallons do I need to have? Let's go back and read it. It is recommended that there be 1 gallon of water for every inch of fish. So if he's 12 inches and I need a gallon for each inch, and I have 12 inches, that means I need 12 gallons. But how many fish do you see? There's 12 inches of fish, but there's only one fish. One fish who's 12 inches long in a 12-gallon tank. Let's see if this might help us. All right. Oh, number of fish and gallons of water. Well, we just saw that there's one fish. And how many gallons of water we decided? 12. Now that we have our ratio set up, go ahead and finish counting and filling in our table. All right, so here we go. We had 1 fish needs 12 gallons of water, 2 fish need 24, 3 need 36, 4 need 48, and 5 need 60. We just made a bunch of equivalent ratios. Let's see if these ratios will help us answer our questions. Letter A, what size tank in gallons is needed for James to have 5 fully grown fish? Number of fish, 5. Looks like we need 60 gallons. How many fully grown goldfish can go in a 40-gallon tank? All right, where's 40 gallons? Oh, it's not on here. But I do know 40 comes between 36 and 48. So I'm going to use my highlighter, and I'm going to say, well, I know it comes between here. Well, that's kind of between 3 and 4. So we can't say 3.5 because it says how many fully grown goldfish. We can't have 3.5 of a fish. So if I have 40 gallons, which would be right here, the most amount of fish I could fit into there would be a 3 full fish, not a part of a fish. So we'll say 4 fully grown goldfish. And letter C. What can you say about the values of the ratios in the table? Well, you probably know the answer to this already because we've done it over and over, but I can tell you right now the value for this one is 1/12. If I reduce this, it's 1/12. If I reduce that, it's 1/12. So if you noticed, all of the values are equivalent. Okay, well, thank you for paying attention, and I hope you guys do well on your assignment.